I feel like between 3.5 and 3.6, the graphs eventually tended to blur together because in the beginning, we're not dealing with things like your vertical shifts and your phase shifts, and then at the end they got together. So I would say there's not like a question that's just from 3.5 or a question that's just from 3.6. It's kind of a blend together. There are questions where it's going to there's one where it just says graph the function. You have to graph the function. And then there's ones where you have to read the graph and get the equation. And then there's, one based on data and quite a few based on words, because that's how heavy this section was. Some where you're just finding out the period and the amplitude. Some where you have to give me the equation, that kind of thing. So as I go through this, keep in mind that it may not be just something from here. Like it might be just say number 1, but it might also have a phase shift in there, or it might have a period adjustment, or it might have a vertical shift. Does that make sense? It's not going to just be an amplitude change. It's going to be multiple different parts that are changed, okay? So with those, it'll ask to find the amplitude, the period. It could ask for the frequency, all that stuff. So questions on any of that before we get into vertical shift and the period and all that stuff? Okay, so you should be able to identify an amplitude, find the period, eventually get to ones where you shift them. And I don't care if you literally take them. Obviously, you can't circle and shift like you do in Notability. If you want to graph the original one and then shift your points over and graph 2, but tell me which one's your answer, that's fine. If you want to just go directly to the shifted one, that's also fine.
Do you have to write the points or can you estimate?
I would say the period should be exact, obviously. The halfway point should be exact.
Okay.
But if you were eyeballing, let's say the period is not something easy like a pi. Let's say it's 2 pi over 3. Then I would say I would be a little bit more lenient on the key points themselves. Does that make sense?
But if it's
pi, I expect to see something over pi over 4, something at pi over 2, and something at 3 pi over 4. Yeah. And then, so obviously this one had a reflection, number 3 had a reflection where you'd have to flip it over. And then 5 through 8 was the reverse. 5 through 8 where we're reading the graph and we're getting the equation out of it. Any questions on those? So as you moved into the next section, obviously in addition to just an amplitude change, you could have also seen a change in the period and a change in the phase shift and a vertical shift. All right. These kinds of questions, I would say you're not going to get something that's just straightforward max min. That would be built into a word problem. So you'll have to take all the words out and figure out that the amount of information they have to give you, if they want to know your midline, if they want to know your amplitude, if they want to know those things, they have to give you a max and a minimum point, or at least a way to figure them out, right? It could say it goes up by 5 and then it goes down and then it goes back down by 5. Well, now you know what your change is. There has to be a min point and a max point given to you in some way. And then if they want to know your period or your frequency, there has to be a start and finish given to you some way. So if something is completed in 5 seconds, if something is completed in 2 hours, if it takes a unit of 8, whatever all those things are that's how you find your period. So that kind of information has to get given to you in order to find the period or the frequency. Yeah.
How would you use the frequency in one of those problems? I know there was one where you had to find the frequency.
It literally is straightforward, what's the period, what's the frequency? So you flip the period.
All right.
That's it. Yeah.
maybe a max and then a min, and you have to know to double it.
So I would say if it's a max and a min, use your tricks. The amplitude is max minus min over 2.
Mm-hmm.
And your midline is max plus min over 2. I would use those.
What if they want to know the period, though? Then
You have to have a start and finish.
okay.
Yeah. Or it would have to say it hits the max at this point, it hits the min at this point. It would have to establish that pattern. I feel like it's not that tricky.
Mm-hmm.
It's pretty straightforward. I mean, in a word problem form.
So you'll get a
But
max and a min.
you'll either get a max and a min, and it's asking for amplitude or midline, or you'll get a start and a finish at some point. Or it gets halfway at this point, and then you have to figure out that it double it, that kind of thing. But it would to be able to establish the period and the frequency. Okay, how about, so now we got into, now we were changing our period and we added in the vertical shift. That's what 3.6 did. So all of these now you should be able to find. Your max value, your min value, your amplitude, your midline, your frequency, your period. And I would say you want to know how to do it from an equation like these are. You would want to know how to do it from a graph. Yeah. Sure, 3.5. Yeah. And then on the bottom, here was the information. You have to give me the equation. Yeah. Daniel.
This is 3/6, right?
This is 3/6.
For the graphic ones, is it okay? Because like you see how like the thing that's given like already has the intervals for the x.
Yes.
Is it okay if like I crossed out and made my
Sure. Yeah, and it's the exact same graph on your test. You mean like you change these? Like you said, this doesn't make sense here, so you change these values, the key points? Yeah, that's fine. True.
For number 5, do you have to put, like, am I putting x or are you putting theta?
Oh, it doesn't matter. Variable is a variable. You could treat it, and you could do it as, like this could have also been 11 sine x over 3, like that, plus 3 could also be written like that. It's the same. So if your b is a fraction, you can either write it on the front like that, or you, like this, like on the front here, or you could build it into the fraction, like the second one. And when it says to write the equation, I don't care what variable you use. Yeah.
Is the test like what is the time? Because like what is the time in the morning? Like would we get like 40 minutes? Like how
You get 45.
45?
Yeah, you always get 45. Yeah.
How many questions?
It's 17. So the period comes from B. B is what's attached to the x in this case, right, which is 1/3. So the period is 2 pi over B. So it'd be 2 pi over 1/3. 2 pi times 3, which is 6 pi. That's the period. And then the frequency is literally the reciprocal of it. Just flip it. So if you get one, flip it to get the other.
Can we go to 3?
Yeah. All right, this was the end of 3/6. So now you got the graphs and you had to find the equations for sine and cosine. Again, I use theta on these, but you could use any variable you want. Yeah. I didn't yet. I will post them. Yeah, and I have them to go over. The max here is 1 and the min is -5. So to find the amplitude, I would do 1 minus a -5 over 2. So it's 3. Yeah. Dan.
Do you say your midline is always the outside?
What do you mean?
Like their midline is -2. Their midline's 1.
What do you mean the outside?
Like what you're adding or subtracting.
Yeah, it's the vertical shift. Your midline is your vertical shift and vice versa. Vertical shift is your midline. Yep.
For number 9, I put something else, but I feel like
Did you add a phase shift? Okay, then 3/6. So I think a lot of this, especially the beginning, was a lot like before, okay? You have to find your max is the easiest. Find the max, find the min, and that gives you the add them, divide by 2, or sorry, subtract them, divide by 2, that's your amplitude, add them, divide by 2, that's your midline. And I'm gonna be nitpicky about the midline, it has to be an equation, so it has to be y equals for your midline, okay? And then the period of the function, you should be able to establish that from your graph by literally just by like looking for when one full curve completes. There might be there is, not might be, but you might get something like this in which it's built into a word problem. It's gonna give you the function, like don't let the words freak you out. It could say 800 words, but it says here's y equals this. What's the period? You should be able to find it just from the equation. So don't get too hung up on the word problem itself, especially if it gives you the function. All right, this is the last part of 3/6, right? Yep. Where's this one? Yeah, okay, so this one, like when it's written like these, when you have a B and a phase shift, then I will take this question, like if it was find the equation, I will take it like this, and I think I wrote it on the review, right, the solutions. Or you can also distribute that in, and I would take it like that. So you don't need to distribute it if it had a B other than 1 and a phase shift, and you're giving me the equation. You don't have to distribute it in.
Where is the 2 from?
The 2 is, so the period goes from here to here, right, is pi. So then if your B, what's here? B is 2 pi over the period, which would be 2. That's the B.
Where'd you get your minus pi over 4?
Because there's a shift. So this is if it's sine. If it's cosine, there is no shift because it starts here, comes down, and goes back up again. But if you did sine, it has to start here Or it could come back here, start here. Either way, there's a shift forward or back.
So it could have been plus part of 4 too.
Yeah,
Okay.
yeah. I tried to be specific on the equations. It will either say cosine or sine. But obviously, if there's a shift in your phase shift, it could go both directions. You could go to the right or you could go to the left. Yeah.
How do you know how far you have to shift it? Like, how did you get that pi over 4 number?
Because it's back between, so like which one was that? The sine one. So if they started with sine and it was -3 sine. So this one, you're going from here down, right? That would be your midline. So that would be 1 cycle. Right? And I approximated it, or they approximated it, but it's halfway between 0 and pi over 2.
So like something on the test, like if we.
I tried not to make it guesswork on
Oh,
the
okay.
test. If there's a shift, it should
It'll
fall
get
in
it.
line with one of the key points so that it's obvious. I don't need 700 approximated different kinds of answers either. Yeah.
You don't want us to distribute.
You don't need to. You can. And if it was multiple choice, which this would be, if this was multiple choice, then I would make sure that you know that it can be, because most of the other ones had distributed it. It's funny, AP Classroom had some where they didn't, and they had some where they did. So it doesn't matter.
Okay.
Yeah. Danielle.
Why can't it be both plus and minus pi over 4?
It can be.
I know why.
Why?
Yeah.
Well, because if you switch it, so this one is forward, right? So you slid it forward, but it started down. This one, it started backwards, but you started it up because it's positive. So you could choose. Like this one, if I come here and start my period here, I go here to here, that's your normal sine curve. So the amplitude is positive. But if I shift it forward, I come down first and go up again. Now it becomes -3 pi over, or 3 for the amplitude. But both produce the same graph. Yeah.
But doesn't -pi over 4 move it right?
-pi over 4 moves it right. So this one moves it right.
And then it'd be -3 sine.
Are these
Wouldn't it?
switched? 3 positive. That's this one. Move to the right. Oh, that should be the negative and that should be the positive. Right?
Yeah, that's what I put.
Yeah. That's funny. I didn't even catch that. That should be switched. That should be the negative. That should be the positive. That's what happens when you trust other people.
Vicky Carter.
Yeah. All right, I'm going to type the data in. You should be doing the same. 41, 44, 47, 50, 56, 61, 65, 66, 61. Ooh.
Do you use that data for A, B, and C, or do you only use it for E? Because it says to make the synthesis. So whatever function at D.
You would be using, according to your model, so your equation is what you use E and F. Is that what you're saying?
I did the first 3 without.
Yeah, I did the first 3 without the thing and then.
But then you're finding it, but then it asks you to write it, right? Write a function. So the one on your test, you will have your calculator because it is like not data. You can, like if it was points matching, so I would say like if your input values were angles on your unit circle, then I would expect you to be able to do this stuff without a calculator. But these are not unit circle based, so you will be using this based on, no,
Not getting anything?
no. But so the only data driven one is this. Yeah,
Cause I got like the amplitude,
yeah,
and then I scooted it 1 over.
okay.
And then I got the midline.
What do you mean scooted it over?
Like I did the -1.
But you would have to do max minus min divided by 2 for amp, max plus min divided by 2 for midline. Is that what you're talking about? 47, 50, 56.
I don't know. Like how do we know when we use our calculator?
It's gonna say use your calculator, and you're gonna have your calculator.
So we're pretty close. If it asks you to write something that's modeled, it means use your calculator. Because
Not
I didn't-
necessarily, based on data for this test, yes.
Yeah.
Not necessarily always. You could have had a T-chart in which you had angle measurements as your input, like pi over 2 and pi and 3 pi over 2, that kind of thing. You could come up with a model, an approximate of a model,
Yeah, it's-
without a calculator, correct. But this kind of question is not even gonna have this stuff, it's gonna jump right to write the model for your
Okay.
test. This should be an easy question if you practice the calculator part. You've done it like 6 times, it's just a different regression.
So it's not gonna have A, B, or C?
No.
Okay.
But, yeah, go.
No, so
Oh man, I did 1 and 2 different.
I have the equation of like all the numbers, and it says find the amplitude. Am I just like deconstructing that equation and I just need to answer?
So if you weren't given your graph, a calculator on this part, then I would expect you to be able to do max minus min
But
divided by
for the
2.
vertical shift, we wouldn't really be able to figure that out.
Correct. Well, no, that's your midline. Your vertical shift is your midline.
Because your midline has to be between 73 and 80.
But what I'm saying is, like, for a question like this, we have a calculator the whole time. So
You
like,
have a calculator.
I can just put a
You have a calculator with one that has data. The one that has a built-in word problem where your max is this and your min is this, you don't have to have a calculator. Right. Okay. So I would say, first of all, being able to understand what this shape overall looks like is going to be beneficial. You don't have to plot this exactly, but if you pay attention to your data, it starts low, and then it goes up, and then it comes back down again. So I know my overall shape of this curve, okay, to kind of help you understand max and min. But also, if you just looked at your lowest value and your maximum value, that helps you with your amplitude. So 66 minus 41 divided by 2. This would be, again, if you had data, if you had like a word problem that gave you max and min without a calculator, so that's 12.5. Then your vertical shift is based on your midline. So we do 66 plus 41 divided by 2. And that's y equals, thank you, 53.5 is your midline, which means my vertical shift is 53.5.
I put plus, is that like?
Yeah, that's fine. And then what's the period? That would be based on how long it took you to go up and come back down again, which in this case was 12 months or 1 year, okay? It's not exact, but we've talked about this, right? Like real data is not going to produce a perfect model. So then it says, write a sinusoidal function that models the monthly temperatures using t equals 1 to represent January. So with this information, you could do it without a calculator, but on your test, you're going to have your calculator. So, because the numbers won't be so pretty. So you can just go to calc, and then C is sine reg. And then I'm going to do my Y1 to store it because it asks for a question later. And I should get, and note that this model, when you look at the top thing, says A sine BX plus C plus D. So the B is being multiplied by the X, and it's already distributed to the C. So I don't have to take that back out. I literally just write it the way that the calculator has it. So this would be 11.837 sine. The B is 0.554x. The C is negative, so minus 2.449, so 450. Plus D is 53.355. So with your calculator, which is going to be more accurate than just approximating it, which is what your test is going to ask you to do.
So Ms. Chris, on the test for A, are we putting?
It's not going to ask you for A on this. It literally just says, what is the regression? And then a question like, according to your model, what's the average monthly temperature in February? How does it compare, maybe? Or according to your model, what's the average temperature? What happens the next year? And so you would know how to go beyond it. Like, what happens the next November? You'd have to count how many months that is forward. Does that make sense?
Yeah.
That kind of thing. Danny.
How would you determine if it's sine or cosine without a calculator?
Without a calculator, I would say that I would assume that this is cosine, but it could also be sine with a phase shift. Yeah.
Wait,
Your calculator only does sine.
Oh, really?
It only does sine.
so it's gonna say find the sinusoidal regression. It's only when you calculate it.
Correct.
You write
Well, sinusoidal is sine or cosine. The only one your calculator can find is sine.
So you write the sine.
You write the sine one. Yep. So when I do Y2, I get 41.829 degrees compared to what's the actual in February. February is 44, so the model overestimated.
It overestimated?
Yeah, because the model would have done, the model underestimated, sorry, 41. The model underestimated. I don't know why I thought that's approved. And specifically in February or at month 2 February, the model underestimated by 44 minus 41 point. Oh man, I lost it. 44 minus 41.82 by 2.171 degrees. Then in October, it should have been 53.918 degrees, and it was 54. So that also underestimated it.
This first one for the questions that ask, what's it going to be next October? Wouldn't it be the same value?
No.
This October? So if I put like 22.
No, because it's not perfect, right? That October would even be wrong. If you do month 10, it's wrong.
No, but would I get 53.91 if I put in the 22nd month? Because this is
Yeah, it's single. Yeah. Yeah.
So like for the vertical shift amplitude and the period, they kind of don't fit.
Well, that's because, again, your data is never going to be, if it's real world data, it's never going to be the perfect model of your sine graph. So I think the wording I put on the test is using the regression model, determine what? Correct. Yep. Yeah. All right, so the 7 was your music. So this time you get a model. It says, what's the amplitude of this model? You guys skipped these. Shame. These should not have been hard, okay? Your amplitude is 0.5. What's the period of this model? B is 660 pi. So it'd be 2 pi over that. Or 1 and over 330. And the frequency is the reciprocal of that, 330 cycles per second. For number 8, now you've got a cosine model. Okay, again, the rodeo performs spins the lasso, blah, 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 blah. It doesn't matter. All I need is this part of it. Unless it asks you for some application of that real world stuff. What's the highest point reached? So if I were to approximate what this graph looks like, if you need the visual, it's a cosine with a negative amplitude and it's shifted up 3.5. Without the positive 3.5 shift up, I would have started at -3. I would have gone up and come back down again. But then it shifted up 3.5. So this whole thing went up 3.5, which means my model is starting at 0.5, going up and coming back down again. So what's the lowest point? 0.5. What's the highest point? My amplitude plus 3.5. So 3 plus 3.5, which is 6.5.
So you wouldn't get a calculator for that.
Correct. Where it's the period of the function, I'm taking b, I'm putting it under 2 pi. So 2 pi over 5 pi over 3. 2 pi times 3 over 5 pi. The pi's cancel. And I get 6 over 5. Okay, -3 cosine 5 pi over 3 times 25 plus 3.5. That's what you're finding. And that answers 2.
And then to give you
All right, 13 is back to your model. So can you plug those numbers in? Can you find a sinusoidal model? And then can you answer questions based on this? Are we okay on 13? Okay. I would say that the tricky part of this one is where t equals 0 is not at the bottom. If you loaded on this Ferris wheel at the bottom and it told you how long it took to make a whole revolution and you knew the rest of the information, I would say that that is a fair test question. The fact that they shifted t0 to not at the bottom, it made this trickier, more tricky than you will see on your test, okay? But if it, so like, it says all the information is in the top there. It says that whatever, the last seat is filled, the Ferris wheel starts, your seat position is shown in the figure. So this is technically where that starts. Then it says that t obviously is the number of seconds that elapsed since the Ferris wheel started. You'll find it takes you 3 seconds to reach the top. So the t from here to here is 3 seconds. And that 43 feet above the ground is the highest point. So your max is 43. The wheel makes a revolution every 8 seconds. That means the full wheel is 8 seconds, which means the period is 8 seconds. That means from here all the way around is a total of 8 seconds. And that means that if I went 3 seconds from here to here, half the circle is 4, and it'd be 1 second from the bottom to there. I think that's where it gets harder than you're going to see on your test. If you loaded at the bottom, and this was t of 0, and it said it took you 8 seconds to go all the way around, you should be able to tell me that that's a period. And it told you the top was 43 and the bottom was 3 feet. That's your max and that's your min. Now you should be able to get your amplitude. That part, I think is fair game for your test. It says the diameter of the wheel is 40 feet. So from here to here is 40, which means the bottom is 43 minus 40. So the bottom is 3.
Then how is T 3 feet off the ground?
T is not 3 feet off the ground.
T is time.
This T is your time. So they're saying they're starting T when you've already moved on. That's why I think it got confusing. Like you loaded in the cart, they didn't start the timer yet. They waited until you shifted up. Then they started the time. That's why I think this is confusing. More confusing you'll see on your test. If T equals 0 was at the bottom, then I think this is a fair question. Because you'd start at 3 feet. So like if I had a model, I'd start at 3 feet. It goes up to 43 feet and it comes back down to 3 feet. This is 8 seconds. My max is 43. My min is 3, which means 43 minus 3 over 2. My amplitude is 20. And my midline is 23. So my vertical shift is 23. My amplitude is 20. And initially it would be cosine. This, if I started my cosine here, what has to be true about the A? It's negative. So I either have to work with my phase shift or I have to use a negative A. So I can make it negative A, which is 20, cosine. If the period is 8, then B equals 2 pi over that, which is pi over 4. And my vertical shift is 23. Y equals, that would be my cosine function. Yeah. So on the original one or on this one? Well, it doesn't matter. On what I just made, your maximum point would be here at the top, which would be 4 seconds and 43 feet. Yep, because it's 8 seconds all the way around. So at 4 seconds, you're at 43 feet. And then if it wanted another one, I'd have to go 8 more seconds. So it'd be 12 seconds and 43 feet. Initially, it was 3 and 43 because it didn't start there. And the min is 3 feet. No, sorry. Are we saying based on it being on the bottom? The minimum is 8 and 3 feet. And then what happened at 16, 3 feet. But based on the original question, it would be 7 because you're taking off this one. Yeah.
First, for the cosine, you have to take into account the phase shift.
Not with the one I just made. Because you're starting at the minimum and going up. If the T equals 0, then yes.
I was talking about like from 1 to 2 though.
Yes.
You do have to.
Yes. But you're not gonna, that won't happen. So I wanna, yeah. Yeah.
Where's the phase shift?
Yeah.
And also,
It said the figure below shows the depth of the water along a seawall. The depth is 5 feet at low tide and 11 feet at high tide. On a given day, low tide occurs at 6 a.m., high tide occurs at noon. Already there you have all the information you need. You have your min is 5 feet. It's also in the diagram, but you don't even need it. Your min is 5 feet. Your max is 11 feet. That's how low it gets and how high it gets. Then it says on a given day, low tide occurs at 6 a.m., high tide at noon. So here's my low, here's my high. Does that mean my period is 6? What would be the period? 12. It's going low, high, low again would have to be another 6. Does that make sense? So the period is 12. So let's get amplitude. Amplitude is max minus min divided by 2 or 6 divided by 2, which is 3. The midline is 11 plus 5 over 2, 16 over 2, which is 8. So y equals 8 is my midline and my vertical shift. Now it starts on this graph. It starts at high tide. It comes down and goes back up again. So my cosine is going to be positive. My amplitude was 3. Cosine. I don't need a phase shift because it hits its max point at the beginning. So I could do theta or t, actually, is what it gives you. Oh, but I need b. Yeah. So if my period is 12, that equals 2 pi over, nope. Let me switch it, sorry. B equals 2 pi over the period. Then B equals pi over 6. Then I get T plus your vertical shift, which is 8. That's a very likely level question. Yeah.
Are we gonna get it like that before we count the graph?
Yeah.
A lot?
There's only one graph on your whole test. Actually.
How is the review like good?
Yeah. Is the review like good? Yeah. I thought we were gonna do, I don't know, I was delusional today. I was like, oh, it's time for a class kick. So I have extra questions on a class kick to practice. That includes your regression, the calculator regression. So I just put it on the assignment. We ran out of time in the last class. I just put it on the assignment. I would say definitely do those. And then we talked about it. I'll give you back your quizzes. We'll talk about that. But we talked about it after the quiz. Do you remember? Yes, the circuit one. I said it won't be on the quiz, but it's going to come back on your test.
Yeah.
Oh, man. Okay. The 3.3 circuit one, which had the questions where you had to find the vertical distance between 2 points. Like if I gave you this angle and I gave you this angle and I asked you to give me the distance between them, you're comparing their signs. That's from here, right? If I want to know vertical distance, I would do sine of this one minus sine of this one because that's my vertical distance. And if I wanted cosine, or if I wanted horizontal distance here, now I'm comparing their cosines. So it'd be cosine of this guy minus cosine of that guy. Those were on your circuit practice, and the ones that had like the equilateral triangles. That were the radii.
So we have. Wait, is this on the review?
That's on the circuit review.
Okay, so
That's on 3.3.
so we still.
So this is the 3.3 extra practice that I told you. All the ones that are circled in green are the same kind of question, and all the ones circled in purple-ish are the same kind of question. You're going to see one of each of those. One of each. All right, this question says, find the A, B, C, and D from the graph. Find the period, the amplitude, the frequency, the midline, and then the cosine equation. So when you look at this graph, one, it's cosine, so that helps me figure out my pattern. If I start on the y-axis, go down and come up again, I've completed one cosine curve from 0 to 1/2. That makes the period 1/2. The max point is 3. The minimum point is 1. That makes my amplitude 2. Or sorry, that makes my amplitude 1. And then your midline, if I add 3 and 1, I get 4 divided by 2. And my midline's at y equals 2, which you can also see from the graph. Because the period is 1/2, the frequency is 2 because it's the reciprocal. There's no phase shift because it starts here, but there is a reflection. This is a cosine curve going upside down. So I'm going to make my A negative. The midline shift means there's a vertical shift up 2. That's D. So A. All right, so the A is your amplitude, which is 1, but it's going to have a negative sign because it's a reflection. The period is 1/2, so B would be 2 pi over that. 2 pi times 2, which is 4 pi. There is no C because there's no phase shift, so C would be 0. And we just said D is our vertical shift, which is also the midline, which is positive 2. So I get y equals negative cosine 4 pi x plus 2. All right, number 2 is based on a data chart. So you're going to enter in all of that data into your calculator. Okay, once you enter in the data, you're going to run the regression, and I get y equals 17.652 sine b 0.487 x minus c 1.799 plus d 58.594. Then it says use the regression to predict the output value when the input is 16. So I just do y1 of 16. And I get 53.512. All right, number 3 says the water in the marina rises and falls with the tides. At high tide, the water hits 2 feet over sea level, and low tide that occurs 5.5 hours later is 1 foot below sea level. Find the equation for the cosine function. So if I draw my axis to get a visual, if it starts at 2 feet at high tide, and then it goes down and goes down to -1 at low tide, and then it would come back up. And it says this from high tide to low tide is 5.5 hours. So I needed to come back up, which means I needed to go another 5.5 hours, and this would be 11 for the period. Your midline, well, your amplitude is 2 minus a -1 over 2, which is 3 over 2, or 1.5. And it would be positive because it starts up. And then the midline is 2 plus a -1 over 2, which is 1/2. So y equals 1/2 would be your midline, and that's your vertical shift. So I get y equals amplitude 1.5. Cosine, it starts on the y-axis, so there's no phase shift. The period is 11, so b is going to be 2 pi over 11. Plus your vertical shift, which is 1/2, or 0.5. And number 4 says the data collected from the temperature in a city generated the following function: y equals 5 sine x over 3 minus 1. Find the period, the amplitude, the frequency, midline, and then graph the function. So my amplitude is 5. The b here would be 1/3, so the period would be 2 pi over 1/3. 2 pi times 3, which is 6 pi. The frequency would be 1 over that, so 1 over 6 pi. The vertical shift is -1. That's your midline, so y equals -1, and then graph the function. So midline at -1. Period is 6 pi, so it's going to come. You can go in each direction if you want. Or you could say this is 4 pi and then come all the way over. This is 6 pi. Amplitude is 5. It's sine, so we're going to start at 0 but shift it down 1. So we're going to start at -1. A quarter the way through 6 pi is 3 over 2 pi. That's the first key point. So it would have been at 5, 1, 2, 3, 4, 5, but then it shifted down 1. Then halfway between 0 and 6 pi is 3 pi. That's where it's going to come back down to -1. It's going to go down underneath 6 pi times 3/4. So 9 pi over 2, or 4.5 pi around here. It's going to go to -6 because it should be an amplitude of 5, but we shifted it down 1, 2, 3, 4, 5, 6 here. And then we come back up to, not there, to -1. That would be the graph of your original function.